Children, try that the background noise should be minimized. Okay. So, infrared rays, you can start your presentation. Others, please try to keep the background noise minimum.
Those who are
Infrared,
not presenting can mute the mic.
I've muted them, everyone. I'm just
Good morning. Team Rainbow would like to present to you a short presentation on infrared radiation. Infrared radiation, sometimes called infrared light, is electromagnetic radiation with wavelengths longer than those of visible light. It is therefore generally invisible to the human eye. Infrared light wavelengths extend from the nominal red edge of the visible spectrum at 700 nanometers to 1 millimeter. Most of the thermal radiation emitted by objects near room temperature is infrared.
Discovery of infrared light. Infrared radiation was discovered in 1800 by astronomer Sir William Herschel, who discovered a type of invisible radiation in the spectrum lower in energy than red light by means of its effect on a thermometer. If a thermometer having its bulb blackened is moved from the violet end towards the red end of the spectrum of visible light, it is observed that there is a very slow rise in temperature. But when this thermometer is moved beyond the red extreme, a rapid rise in temperature is noticed. It means that the part of spectrum beyond the red extreme of the visible light has certain radiation which produce a strong heating effect but are not visible. These radiations are called infrared radiations. Detection of infrared light. A thermopile can be used to detect the heat radiations. The galvanometer connected with the thermopile shows deflection when infrared radiations fall on the thermopile. The spectrum of infrared radiations is obtained by using a rock salt prism because the rock salt prism does not absorb the infrared radiations, whereas a glass prism absorbs them. By moving a thermometer with its bulb blackened from the violet end towards the red end of the spectrum of visible light and then beyond the red extreme where a rapid rise in temperature can be noticed due to the infrared radiations.
Sources of infrared radiation. Since the primary source of infrared radiation is heat or thermal radiation, any object which has a temperature radiates in the infrared. Even objects that we think of as being very cold, such as an ice cube, emit infrared. When an object is not quite hot enough to radiate a visible light that is around 5 Kelvin, it will emit most of its energy in the infrared. For example, hot charcoal may not give off light, but it does emit infrared radiation which we feel as heat. The warmer the object, the more infrared radiation it emits. All red-hot bodies such as heated iron ball, the sun, flame, fire, etc. are sources of infrared radiations.
Properties of infrared light. They travel in straight lines like light with speed equal to 3 into 10 to the power 8 meter per second in vacuum. They obey the laws of reflection and refraction. They are absorbed by glass but they pass through rock salt. They are detected by their heating property using a blackened bulb thermometer or a thermopile. They are scattered less by the Earth's atmosphere because of their long wavelength. Hence, they can penetrate deep inside the atmosphere, even in fog. The greenhouse gases present in the Earth's atmosphere absorb the low energy infrared radiations and keep the Earth's surface warm.
Anyone who cannot mute themselves? Who will be speaking about infrared uses?
Infrared radiations are used for therapeutic purposes by doctors. They are used as signals during the war as they are not visible and they are not absorbed much in the medium. They are used in remote control of television and other gadgets. They are used in photography at night and also in mist and fog because they are not much scattered, so they can penetrate appreciably through it. Infrared waves have longer wavelengths than visible light and can pass through dense regions of gas and dust in space without scattering and absorption. Thus, infrared energy can also reveal objects in the universe that cannot be seen in visible light using optical telescopes. Harmful effects of infrared radiation. The infrared radiation in the sunlight causes damage to the skin. In direct sunlight, the temperature of human skin rises to about 40 degrees Celsius as it converts the absorbed infrared radiation into heat. The most common eye disease associated with near infrared radiation is cataracts. Prolonged exposure to infrared radiation causes a gradual but irreversible opacity of the lens. Other forms of damage to the eye from infrared exposure include scotoma, which is a loss of vision due to the damage to the retina. Thank you.
Okay, thank you. Now we move on to team ultraviolet rays. Can you just raise your hand so that I can make you the presenter? Team ultraviolet rays. After that, we'll move on to Vibgyor. Team ultraviolet rays, please raise your hand. Okay, now you are the presenter. You can start your presentation. Anyone who is not a presenter of your team, who is a team leader, just
Ma'am,
check. Yes, just check whether team ultraviolet rays all are presenters. Anyone who is not the presenter, can you just unmute yourself and tell me that you're not the presenter? Okay, so we
Am
start.
I?
Okay, then we start with um, the team ultraviolet rays.
ma'am, Pallav should be starting the screen sharing, but
Where is
he, he's not a presenter as of now.
okay? Paul, look, and where are you? Just raise your hand. Paul was in the meeting. Paul, just call Paul. By mistake is Paul, just call him in the meeting. Paul, I think is left out from by mistake. Did he leave the meeting? I cannot find him here. Can anyone text him to join the meeting?
Ma'am, I've texted him.
Is he facing any network issue problem? Because he was there in the meeting, I've seen him. Next team, Vibjia, get ready, okay? After this, it'll be yours.
Okay, ma'am.
Uh, Sharat, can we just switch on to your team and give them a chance for Pallav to enter so that we don't waste time?
Yes. Yes,
Okay,
ma'am.
then.
We can.
Okay,
No
then.
problem.
Okay, then we'll wait for Pallav to enter. Shomadip, just find out what's the problem he's facing and just let me know.
Okay, ma'am.
Uh, and Sharat, then we'll switch on to your team, Vibjir.
Okay, ma'am. Yes, ma'am.
Uh, just raise your hand, children, so that I can.
Ma'am, I cannot get the option of raising hand.
Okay, what's your name? Just tell me.
Ma'am, Srinav Shaha.
Okay, Pranav, I'm making you the presenter. Others, put your hands down. Only Vibjir team, can you just raise your hand so that I
Ma'am,
can. Yes, Rishita, we are here.
ma'am, Rishita.
Yes, what happened?
Ma'am, I can't log in from my computer.
You can't log in for your from your computer. Can you send the PowerPoint to someone who can share?
So, ma'am, how to send the PowerPoint? You send it.
Uh, so then do one thing. We'll move on to the next team. Just tell, because it's the first time you all are doing, you'll face a problem. No tension.
Yes, ma'am.
Anuran sir is not like that, that he understands. Okay. So this is the first time you all are doing online. No problem. Do something. Try to get that PowerPoint, any one of you. Okay, I'll give your team at the end. You are getting 20 minutes time. So try to get the PowerPoint from her and any one of you take the initiative to present.
Okay, ma'am.
Okay, then lower your hand. We'll move on to,
Thank you, ma'am.
the next one. Microwaves, radio waves, microwaves, radio waves, microwaves, radio waves. Yes, get ready, children. Just raise your hand. So just try to get the PowerPoint from someone, through someone.
Yes, ma'am. Sure. We are trying to do so.
So your topic is radio waves and microwaves, children. Get ready. Okay. See, we are here to learn, and Onuram sir is not like that. As you know him, you'll understand he's very he's a different type of person which you're thinking. You're so tensed. No problem. Nothing to be tensed with. We are all here to learn. We are also learning. Okay. So, are you ready, team radio waves and microwaves?
Yes, ma'am.
Okay. Can we
Yes, ma'am.
start?
Yes,
All our
Yes, ma'am.
presenters,
Start.
all our
Yes, ma'am.
presenters in your team.
Yes, ma'am.
yes, ma'am.
Okay. So we are going to learn radio waves and microwaves. Children, don't take it as a competition. In every competition, you have first and second, but learning is more important. Okay. So we are all going to learn. So you can start your presentation. Team radio waves and microwaves.
A very good morning to one and all. Team Sound brings to you a short presentation on radio waves and microwaves. Before we start, I would just like to give a short description of electromagnetic spectrum. Electromagnetic radiation in physics refers to the waves of the electromagnetic field propagating or radiating through space carrying electromagnetic radiant energy. The complete electromagnetic spectrum in the increasing order or of their wavelengths or decreasing order of their frequencies is gamma rays, X-rays, ultraviolet rays, visible light, infrared radiations, microwaves, and radio waves.
Radio waves are a type of electromagnetic radiation with wavelengths in the electromagnetic spectrum longer than the infrared light.
Sources of radio waves. Radio waves are generated by electric charges undergoing acceleration, such as time varying electric currents produced by time varying magnetic fields. Naturally occurring radio waves are emitted by lightning during lightning discharges and astronomical objects. Radio waves can also be artificially generated by transmitters and received by radio receivers using antennas. They are also generated and transmitted by satellites and radar, favoring long distance communication.
Characteristics of radio waves. Radio waves have frequencies as high as 300 GHz to as low as 30 Hz. At 300 GHz, the corresponding wavelength is 1 millimeter, and at 30 Hz is 10,000 kilometers.
Uses of radio waves. These waves are used mainly in radar communication and also in radio and television transmission.
Microwaves. The microwaves have wavelength in the range of 10 to the power 7 Armstrong to 10 to the power 11 Armstrong, or 1 millimeter to 10 meter, or frequency in the range of 3 into 10 to the power 11 Hz to 3 into 10 to the power 7 Hz. These waves are produced by the electronic devices such as crystal oscillators.
Characteristics of microwaves. Microwaves are at the higher frequency and the end of the wave band, and low frequency radio waves are at the lower frequency end.
Microwaves are used for satellite communication, for analysis of atomic and molecular structure, for cooking in microwave ovens, and in radar communication. Microwave radiation penetrates the body. The exposed molecules move about and collide with one another, causing friction and thus heat. This is known as thermal effect. If the radiation is powerful enough, the tissue or skin might get heated or burnt. Thus, we can say that the biological effects of electromagnetic radiation do not necessarily feed into these artificial divisions. Thank you.
Ma'am, we can't hear you.
X-rays is Paul Loeb inside the meeting?
Yes, ma'am.
Is Paul Loeb inside?
Yes, ma'am.
Okay. So Paul Loeb, we are doing X-rays and gamma rays. After that, your team will come. Okay.
Okay.
Get ready after this team. Team X-rays and gamma rays, please raise your hand. Others, please lower your hands, children. Team X-rays and gamma rays, raise your hand. Get ready with your presentation. Who is going to present in your team?
I'm Swamdip.
Okay. So get ready, children. All the best. Don't be tensed. We all are learning. Okay. From the points. I think you'll be a better teacher than me because you all are covering all the points. And since you all are small children and you all are so far apart, but still you tried your best within the short notice to prepare this, shows what you can do if you try.
Okay, ma'am, I am presenting now.
Okay. So all our presenters in your team, anyone who is left out? Okay, children, you can start. Team X-rays and gamma rays.
Good morning, everyone. Today, Newton Group is going to present a small presentation on X-rays and gamma rays, where we are going to discuss its properties, uses, and many more. So, starting off with X-rays. X-rays are obtained from a heavy metal target like tungsten, which has a high melting point. When it is charged with highly energetic cathode rays, then X-rays are obtained. This was first discovered by William Roentgen. As we can see in the picture given aside of the electromagnetic spectrum, the spectrum of X-rays lies just before the ultraviolet spectrum and after the gamma ray spectrum. So properties of X-rays. Wavelength of X-rays ranges from 0.1 Armstrong to 100 Armstrong, which means the distance between two consecutive crests or two consecutive trough of wave of X-rays ranges from 0.1 Armstrong to 100 Armstrong. The frequency of X-rays ranges from 3 into 10 to the power 15 Hz to 3 into 10 to the power 18 Hz. Energy range is 124 electron volt to 124 kilo electron volt. It is not deflected by electric and magnetic field because X-rays are electrically neutral and does not contain any charged particles. It follows all the properties of visible light in air or vacuum, like the speed of X-rays in air or vacuum is 3 into 10 to the power 8 meter per second, which is same as that of light. Now I would request Shubhangi to take over.
A very good morning to everyone. Now, properties of X-rays. X-rays are chemically more active than ultraviolet radiation. They strongly affect a photographic plate. They also causes fluorescence and zinc sulfide. They can penetrate through human flesh but are stopped by bones. Now, this property finds its utility in X-ray photography or cardiography. Uses of X-rays. They are used for the detection of fracture in bones and teeth, that is radiography. They are also used in CAT scan, used for studying atomic arrangements in crystals and as well as in complex molecules. Now I would request Tirthankar to take over.
Good morning, ma'am, and our respected judge, and all my friends. Gamma rays. These are the most energetic electromagnetic radiations. They are obtained in radioactive emissions. It is obtained at the lowest extreme of the electromagnetic spectrum. It was discovered by Becquerel and Curie. In the picture given aside, we can see the position of gamma rays in the electromagnetic spectrum. Properties of gamma rays: wavelength less than 0.1 angstrom, energy level above 100 keV, frequency is above 3 into 10 to the power 19 Hz. They cause fluorescence in zinc sulfide. Now I would like to request Samdeep to take over.
Good morning, ma'am, and respected judge and student and my friends. Today we will discuss the properties of gamma rays. Gamma rays. They can easily penetrate through thick metal sheets and human body as the penetration power is very high. It is not deflected by electric and magnetic field as it does not contain any charged particles. It affects a photographic plate. Uses of gamma rays. They are used in medical science to kill cancer cells, that is radiotherapy. Used in industries to check welding, sterilization, and disinfection. Used in gamma ray astronomy for its high penetrating power. Now I will request Shomabu to take over.
A very good morning to everyone. For better understanding, we have made a comparative study between X-rays and gamma rays. X-rays are obtained from a heavy metal target of high melting point when highly energetic cathode rays are stopped by it, whereas on the other hand, gamma rays are obtained in radioactive emissions when nucleus of radioactive atoms pass from the excited state to the ground state. X-rays have wavelength from 0.1 angstrom to 100 angstrom, whereas gamma rays have wavelength less than 0.1 angstrom. X-rays have frequency from 3 into 10 to the power 15 Hz to 3 into 10 to the power 18 Hz, whereas gamma rays have frequency above 3 into 10 to the power 19 Hz. Here we can say that wavelength is inversely proportional to frequency as X-rays have greater wavelength than gamma rays. Hence, frequency of X-rays is less than that of gamma rays. X-rays have energy range from 124 electron volt to 124 kilo electron volt, whereas gamma rays have energy level above 100 kilo electron volt. X-rays can penetrate through human flesh but are stopped by bones, whereas gamma rays can easily penetrate through thick metal sheets and human body. X-rays are used for studying atomic arrangement in crystals as well as in complex molecules, whereas gamma rays are used in medical science to kill cancer cells, that is, in radiotherapy. I would request Supratim to take over.
A very good morning to everyone. We have prepared three questions which we feel relevant to our presentation. The first question is, what is the principal sources of X-rays? The second question is one numerical, that is, the wavelength of X-rays is 0.01 Armstrong. Calculate its frequency in air. The speed of X-rays in air is 3 into 10 to the power 8 meter per second. The last question is, write one use of gamma rays. The first answer is, X-rays are obtained from a heavy metal target of high melting point when highly energetic cathode rays are stopped by it. The second answer is, we know speed of X-rays in air is equal to its frequency into its wavelength, which implies that its frequency is equal to speed of X-rays in air divided by its wavelength, which implies that frequency is equal to 3 into 10 to the power 8 divided by 0.01 into 10 to the power minus 10. Here we are multiplying 0.01 with 10 to the power minus 10 because 1 Armstrong is equal to 10 to the power minus 10 meter. So we will obtain the answer in SI unit, which is 3 into 10 to the power 20 Hz. The last answer is the gamma rays are used in medical science to kill cancer cells, radiotherapy.
We would like to express our heartfelt gratitude towards our teacher, Anusha ma'am, and towards our respected judge, Anurang sir, and our all friends for their utmost cooperation. Thank you.
Thank you, children. So nice that y'all are so far away and how y'all coordinated. It's really nice. It's really nice, children. Within this
Thank you, ma'am.
3 or 4
Thank you
days
so much,
time,
ma'am.
how y'all did it.
Thank
Very
you,
nice.
ma'am. Thank you, ma'am.
Thank you, ma'am.
Uh, we move on to Pallab, your presentation. Can your team just raise your hand? Your team, y'all are infrared rays, right, Pallab?
No, ma'am. Ultraviolet radiations.
Ultraviolet rays. Also ultraviolet rays. Okay, team ultraviolet rays, can you just uh, raise your hand? Children, sir, it's not like that. Why are you so tense? No tension. All our presenters, in your team, Shomadeep,
Yes, ma'am.
all our presenters, right? Anyone who is left out?
No, ma'am. Everybody is a presenter.
Okay, so we start. Others, please mute yourself. All the best, children. All the best. Start your presentation.
Good morning, judges and all the listeners. Today, Team Energy has been entrusted with the job of presenting a short presentation regarding the facts and some very interesting information regarding the ultraviolet radiations. Follow the next slide. So as mentioned before, our topic of discussion of today is the ultraviolet radiations, where we'll be discussing its properties, sources, and the detection procedures. So first, we want to explain where the ultraviolet radiations are located in the electromagnetic spectral chart. So the ultraviolet radiations are electromagnetic radiations of wavelengths ranging from 100 angstroms to 4,000 angstrom, or in simple terms, 10 nanometers to 400 nanometers. The ultraviolet radiations lie between a frequency range of 3 into 10 to the power 16 Hz to 7.5 into 10 to the power 14 Hz. These are high energy radiations and they occupy the position between the X-rays and the violet end of the visible spectrum. The next slide, please. I'll look the next slide. In this picture, we see Professor. Previous slide, Paul, look. So this picture here depicts Professor J. Ritter, the person who is credited with the discovery of the UV rays about 200 years ago in 1801, where he conducted some experiments to discover and detect the presence of UV rays in its vicinity. Now I would like to ask Shomo to take over the reins. Shomo. All of the next slide.
Good morning, everyone. Good morning, everyone. I am going to say about the detection of ultraviolet radiation. The ultraviolet radiations can be detected in the following ways. When silver chloride solution on exposure to electromagnetic waves first turns violet and then dark brown, it shows the existence of certain radiations known as ultraviolet radiation. The second point is the ultraviolet radiations can be detected on dyes and photograph plates. And the last point is the spectrum of ultraviolet radiation through a quartz prism absorbs this radiation. Now I am going to like Somoji to say about the properties.
Although, please say about the sources first. The next slide.
The electric spark and arc give ultraviolet radiations. A mercury vapor lamp emits radiation, a part of which has ultraviolet radiations along with the visible light. Sun is also a source of ultraviolet radiation, but a large fraction of it is absorbed by the ozone layer in the upper atmosphere, which protects us from its harmful rays.
The next slide, please. Now we are going to discuss the properties of ultraviolet radiations. In the screen, we can see zinc sulfide powder, and zinc sulfide fluorescence is caused by the ultraviolet radiations, but it is to be noted that visible light does not cause these fluorescence, as ultraviolet radiations are chemically more active than the visible light, and they have high energy than the visible light because of their shorter wavelength. The next slide, please. In this slide, we can see, or it exhibits the scattering and the significance of the ozone layer in trapping or reflecting back the UV rays. So the UV radiations are usually scattered by the dust particles present in the Earth's atmosphere, and this is known as Rayleigh scattering. Some other properties include their similarities with the visible light. Ultraviolet radiations, just like visible light, propagate in a rectilinear manner with a speed of 3 into 10 to the power 8 meter per second in air or vacuum. They obey the laws of reflection as well as refraction. And as Shomo mentioned before, ultraviolet radiations can pass through quartz. So in bulbs, in ultraviolet bulbs, the envelope is made up of quartz rather than glass because glass absorbs the ultraviolet radiations. The next slide, please. Now we come to the harmful effects of UV radiation, that is UV radiation induced skin cancer. So before we talk about skin cancer, I want to relate when we go to the seashore, what happens for a short period of time, our skin gets tanned. This is not because of the visible light. This is not because of the visible light emitted by the sun, but because of the UV rays, which oxidizes the melanin pigment present in our skin. But excessive exposure to UV radiations causes skin cancer or melanomic carcinomas, skin tumors, and blisters, which might often be fatal. The next slide, please. Now, keeping aside all the negativities, we now highlight the positivities and uses, the constructive uses of ultraviolet radiations. Ultraviolet radiations are used for the following purposes. Ultraviolet radiations are used in sterilization. In the picture, we can see a sterilizing machine which is emitting ultraviolet rays, and it is installed in an ICU, that is intense care unit in a hospital, where it ensures the disinfection of the room and the safety of the patients. Also, ultraviolet radiations are used for detecting the purity of germs, gems, eggs, ghee, etc. And contradictory to what it does to the skin, ultraviolet radiations also produce vitamin D when it encounters our skin, and also in plants and animals too, it produces vitamin D. The next slide. Thank you everyone for your cooperation and effort. We are signing it off here. Thank you.
Excellent, Shivan. Excellent. Excellent. You know, you'll be a better teacher than me. I don't know how I will teach you this chapter next day. I'm supposed to teach you this chapter next day, But it's so nice that you'll have, within this short period of time, how you all could coordinate like this. You all did not even meet each other. Okay. Now, I think only two teams are left out. One is Team Vipture and other is Spectrum as a whole, right? All others. Anyone else is left out, children? Now, Rishita, are you ready with your? Uh,
Ma'am, yes, ma'am, I am ready.
okay. So, Team Vipure, can you just raise your hand? Nice to see your smiling face, Rishita. After trying such a lot to join, very good. I can see.
Ma'am,
Don't worry. You tried your best. What happened, Rishita? Come on. Come on. All the best.
ma'am,
What happened? Why so? Why are you crying? Come on. This happens in the network issue. This happens in the network issue, Rishita. Come on. We're on in an
Yes,
online
ma'am.
mode. Yes, someone was telling me something, children.
ma'am, I do not getting the option of raising hand.
Okay, okay. Trinab. Trinab. Uh, yes,
Ma'am,
Trinab.
I
Trina,
will be
Rishita,
presenting
cool
the
down. Rishita,
presentation.
cool down and get ready with your sharing screen.
Yes,
Okay,
ma'am.
smile, smile. Come on. We are all here to learn from you all. Your hard work. Trinab, Trinab. Trinab.
Network
Trinab,
cannot.
please speak. Yes, yes. Trinab, I am making you the presenter. Okay, Trinab, I made you the presenter. Now, all the best, children. Rishita, first cool down. Until you cool down, this is the first time you all are doing an online presentation, and you all didn't even meet each other. How you all managed to coordinate, I don't know.
Yes, ma'am.
I'm really proud of you, children. At least you tried your best. See, when you try to do something good, okay, you're trying to do something good to learn, so no problem. Keep it up. All the best to your team. We are here to learn, children. Competition should be a healthy competition. You faced network issues, you managed from mobile, laptop. How you tried, I don't know. At such a tender age, you tried your best. Others, please mute yourself, children, and give them a chance to present. They have tried to log in from different devices. Okay, Rishita, now you start. All
Yes.
the best to your team.
Ma'am, from where I will share the screen?
Uh, is there a sharing option? Sharing option?
Ma'am, it's saying only meeting organizers and presenters can share.
Rishita, 1 minute, right? So you are so tense, you did not even raise your hand, so you are not a presenter. Wait, I'm making you a presenter. Don't be tense. Come on, for a simple thing, don't be tense. Okay, now just check whether you can present, Rishita.
Yes, yes, ma'am.
After your tears, I think will you give us a nice presentation.
Ma'am, can you see my presentation?
It's coming, Rishita. It's coming one by one. Yes, try. It did not come yet. Yes, yes, yes. Now you can start, children. All the best.
Okay, ma'am.
Good morning, our respected teacher, Anmesha ma'am, Judge, Anuran sir, and all our dear friends. Today, the team Vibgyor has got an ample opportunity for presenting. Vibgyor, the visible light rays of spectrum.
Wait. স্মাইল ফেসে বলবি বি কনফিডেন্ট টেনশন করবি না একদম দিয়ে ধরা আছে হাসতে হাসতে বলবি আমি মুখে জাস্ট একটা স্মাইল রাখবি
যখন এরকম করে ম্যাম বলছে শান্তি guys getting angry.
Stop the background noise. Come on, come on. Let's start.
Ma'am, should I play it from the beginning?
Continue, continue. It's nice, it's nice. Continue. See, Rishita, the problem is your machine has become a little slow. So you don't have to worry, it will come. By the time the last team get ready, okay? The last team, you'll get ready with your presentation. Their laptop has come a little slow, I think. So it will come. You can do one thing, Rishita. You can stop sharing and then share again. Sometimes it happens. Stop sharing and then share again. You stop your sharing and then share again. It might come. That's because your machine has. Don't worry. You're tense. The more tense you become, can you stop sharing? Yes. Now you share again. It happens. The first time you all are doing it happens. So do one thing. We'll give Sujat. We will try to
Yes, ma'am.
present. Otherwise, what we will do, you can send a recording to Anuran sir. I will send today's recording to Anuran sir. Okay, he will judge again and he will give me the declaration which team, and next day I will declare it in class. Okay, first try,
Yes, ma'am.
and if you cannot, because there's a problem in the network and in your team, what we can do to give justice to your team, you'll give a recording of just after this class. Don't keep a good line. I will add to today's recording. I've started recording your presentations. I will give it to Anuran sir so that he can have a look over it when he gets his time. By next week, you will get your prizes. I will give you your prizes. Okay.
Okay,
So
ma'am.
I'm giving you your. I'm making team electromagnetic spectrum as a whole as a presenter. So you'll find out what is the problem with Rishita's laptop. Okay, after this, you'll again try. If you cannot, give a recording. I'll hand it over to Anuran sir.
Okay,
Okay.
ma'am. Yes.
Uh, team electromagnetic spectrum as a whole. Can you lower your hand, children, Vibjir, so that I can make the other team the presenter? There's no problem. This happens, children. So many times it happens with me. So, team electromagnetic spectrum, can you just raise your hand? Team
Yes,
elect.
ma'am.
That is weird here. Children, make sure that the background noise is minimized. Anyone in your team, anyone in your team is not there. Please just check whether your team members are there.
Okay, ma'am.
Anyone
Checking.
who's not a presenter, can you just switch on your camera so that I can see you? Please make sure that the
Ma'am, everyone
background
is
noise.
present.
Okay. So all our presenters. Okay. So your role in our class today is to give us an overall idea of what we discussed, the electromagnetic spectrum as a whole. I think other than Team Vibjor, all have presented children. Unuron, everyone have given, right?
Yes, ma'am. Yes.
Uh,
Only
so
two teams are left right now.
only two teams are left. So this is electromagnetic spectrum as a whole. So children, all the best. You can start sharing. Others, please try to see that the background noise is minimized.
Ma'am, can you see our presentation?
Yes, yes, we can see children. We can see.
A very very good morning to our judges, Annesha ma'am, and our judge Mr. Anuran Chakraborty, and also a very good morning to my friends. Today we are presenting our topic on electromagnetic spectrum as a whole. Now, in our daily life, we see objects around us due to the presence of visible light, which are visible to our naked eyes. But instead of this visible spectrum, there is a spectrum before the violet end of the visible spectrum and after the red end, which cannot be seen by our naked eyes. This spectrum is known as the invisible spectrum. Note that the invisible spectrum cannot be obtained by any normal prism made of flint glass or something. The quartzite prism or a prism made up of rock salt is generally used to obtain these kind of rays, and because this prism does not absorb these rays. Now, what is an electromagnetic ray spectrum? The electromagnetic spectrum consists of the electromagnetic radiations with their respective range of frequencies, wavelength, and photons range. That means the electromagnetic spectrum includes both the visible spectrum as well as the invisible spectrum that we cannot see by our naked eyes. Types of electromagnetic radiations. There are 7 types of electromagnetic radiations. First is the gamma rays, second the X-rays, third comes the ultraviolet rays, fourth is the visible light, which is visible to our naked eyes and which helps us to see objects around us. Fifth is the infrared radiation, sixth is the radio waves, and seventh the microwaves.
Good morning to everyone. Now I am presenting the properties common to all the electromagnetic waves. Number 1. Electromagnetic waves do not require any material medium for their propagation. Number 2. They all travel with the same speed in a medium, example in different speeds in different medium, example in glass. Number 3. They exhibit the properties of reflection and refraction. Number 4. These waves are not deflected by the electric and magnetic fields. Number 5. These waves are transverse in nature.
Good morning everyone. I will like to discuss something about the gamma rays. The gamma radiations have a wavelength less than 0.1 Armstrong and their frequency is about 3 into 10 to the power 19 Hz. These rays are first discovered by Becquerel and Curie. Now comes the properties of the gamma rays. Number 1. These rays cause fluorescence when they strike the fluorescent materials like zinc sulfide. Number 2. They can easily pass through thick metallic sheets. Number 3. This gamma radiation can easily pass through human bodies and can cause immense damage to our body. Therefore, excess gamma radiation is very harmful for our body. Now the detection. This radiation can be detected by their large penetrating power. Now the sources of the gamma rays. Number 1. This radiation can be detected. This radiation, I'm sorry the screen is not coming now. Abidu.
Yes. Maybe some network issues. Wait and see.
Yes, yes,
I
yes.
can see the screen. I can see the screen. That means it's network issue on the.
Now the sources of the gamma radiation. Number one, these radiations are obtained in radioactive emissions or from radioactive substances. Number two, these rays are found in cosmic radiations. Now the uses of the gamma radiation. Number one, these rays are used in medical science to kill cancer cells, that is by radiotherapy. Number two, these are also used in industries to check welding.
Good morning, everyone. Now I'd like to discuss about the X-rays. X-rays have wavelength between 3 into 10 to the power 16 Hz to 3 into 10 to the power 19 Hz and frequency in the range of 0.01 to 10 angstrom. The discoverer of X-rays is Wilhelm Röntgen in the year 1895. The properties of X-rays are: number one, these rays are chemically more active than ultraviolet radiations. It strongly affects E. X-rays also cause fluorescence in metals like sulfide, etc. Number four, it can penetrate through human flesh, but it's stopped by bones. Now the method of detection. X-rays can be detected by the
Just a
fluorescence.
minute, just a minute. Uh, Anushka, just make sure that when you are speaking, you switch on your mic. There's a background noise. Uh, Kovidu, just tell your team to mute themselves, and when we will speak, let them unmute.
Hello, team members, please unmute your, please mute your mics, and who is speaking about the present topic, only he or she will unmute their mic and stay. Others,
Okay,
please mute their mic so that no background sound can interrupt.
okay, children, start.
Method of detection. X-rays can be detected by the fluorescence it creates on zinc sulfide screen. It all it can also be detected with its effect on photographic film. Now the sources. It is obtained from a heavy metal target of high melting point when highly energetic electrons are stopped by it. Now the uses of X-rays. X-rays are used in detection of fracture in bones, teeth, etc. It is also used for studying atomic arrangement in crystals as well as in complex molecules.
Now, in number three comes the ultraviolet radiations, which is also an invisible electromagnetic radiation. Now, the wavelength of ultraviolet radiation ranges between 100 angstrom to 4000 angstrom, and the frequency ranges between 3 into 10 to the power 16 hertz to 7.5 into 10 to the power 14 hertz. Now, the discoverer of ultraviolet radiations is Professor J. Richter, and is discovered in about 1801. Now comes the properties of ultraviolet radiations. 1. These radiations can pass through quartzite but is absorbed by glass. Number 2, that these radiations also travel in a straight line like light and with a speed of 3 into 10 to the power 8 meter per second in vacuum or in air. Number 3, these radiations also obeys the laws of reflection and refraction. 4. These radiations are scattered by dust particles present in the Earth's atmosphere. 5. This radiation strongly affect the photographic plate and is chemically more active than visible light. 6th is that these radiations produce fluorescence on sticking with a zinc sulfide screen. Now the methods of detection of ultraviolet radiations, how these rays or or these radiations can be detected. They can be detected by their chemical activity on dyes, as they are more active than visible light and have different effects on dyes. Now, two, they can also be detected by their effect on photographic film. And in three, they can detected by their property that they cause fluorescence on striking with a zinc sulfide screen. This is how the ultraviolet radiations can be detected, which we cannot see through our naked eyes. Sources of ultraviolet radiation. From where do we get these radiations? Now, one, the ultraviolet radiations comes from electric arcs and sparks. And two, these radiations come naturally from sunlight. Now, the uses of these radiations. These radiations kill bacteria and other germs, which is harmful for our body and thus is used for sterilizing ears, surgical equipments, etc. And for detecting purity of gems, eggs, ghee, etc. These radiations also helps in producing vitamin D in food of plants and animals, vital for the health of the living organisms. Now, the harmful effects of ultraviolet radiations. If our body is exposed to ultraviolet radiations for a long period, this can cause health hazards like skin cancer and others also.
Now comes the visible light or visible rays. The electromagnetic radiations of wavelength from 4000 angstrom to 8000 angstrom are called the visible radiations. Discovered. This visible part of spectrum was first discovered by Isaac Newton while passing the sunlight through a glass prism. They have a frequency of about 3.75 into 10 to the power 14 hertz, ranging to about 7.5 into 10 to the power 14 hertz. Now comes the properties of visible radiations. Number one, they are visible. Number two, they produce slight heating effect. Number three, they affect the photographic plate. Number four, they do not cause fluorescence. Number five, they do not affect the body. And lastly, they can pass through glass. They are not absorbed by glass also. The method of detection. This visible light can be detected by the other object, as other object can be seen in its presence, since it makes other objects visible to our eyes. And number two, these rays can be obtained by a normal prism made of flint glass. Now the sources. The sun is the main natural source of visible light. Number two, the electric bulb, flame, and other white hot bodies are the main sources of visible light. Now, uses of visible light. The visible light is used mainly used in photography and in plants in photosynthesis for their preparation of food and also to release oxygen in atmosphere. And this visible rays of light makes the objects around us visible.
Number 5, infrared radiation. It is the fifth wave among the electromagnetic spectrum. They have a wavelength in the range of 8000 Armstrong to 10 to the power 7 Armstrong and a frequency of 3 into 10 to the power 11 Hertz to 3.75 into 10 to the power 14 Hertz. It was first detected by Sir William Herschel in about 1800s. Properties. They travel in straight line like light at a speed of 3 into 10 to the power 8 meter per second. They obey the law of reflection and refraction. They do not affect ordinary photographic film. However, specialized photographic films are affected. They are absorbed by glass, but they can pass through rock salt. They are detected by their heating property. They are scattered less by the Earth's atmosphere because of their long wavelength. Methods of detection. It is detected by using a thermopile. The spectrum of infrared radiation is obtained by using a rock salt prism, as rock salt prism doesn't absorb infrared radiation, whereas a glass prism absorbs them. Sources. The sun is the natural source of infrared radiation. Also, all red hot bodies, for example, heated iron ball, flame, fire, etc., are sources of infrared radiation. Uses. Infrared radiations are used for therapeutic purposes by doctors. They are used in photography in dark and also through mist and fog. They are used in the dark for developing of photographs. They are used as signals during war. They are also used as remote controls of television and other electronic gadgets. Harmful effect. A high dose of infrared radiation may cause skin burns.
Number 6, microwaves. Microwaves have wavelength in the range of 10 to the power 7 angstrom to 10 to the power 11 angstrom and frequency in the range of 3 into 10 to the power 11 hertz to 3 into 10 to the power 7 hertz. The microwave was first discovered by Hertz in the year 1886. Now the properties. They have larger wavelength than infrared radiations. It can pass through glass, plastic, and atmosphere but is reflected by metal. These waves show heating properties and also have all the properties of light. Methods of detection. Microwaves can be detected by oscillatory electric circuits. Sources. These waves are produced by electronic devices such as crystal oscillators, radars, microovens, etc. And natural sources are like sun and cosmic microwave background. Uses. It is used in satellite communication, in microwave ovens, in radar communication, and for analysis of atomic and molecular structures. Harmful effects. Exposure to high levels of microwave can cause a painful burn and can also cause nutrition depletion in some species. Number 7, radio waves. Radio waves have wavelength above 10 meter and frequency below 3 into 10 to the power 7 hertz. This wave was first discovered by Marconi in the year 1901. Properties. These are the waves of longest wavelength amongst all the electromagnetic spectrum. These waves also show heating properties and shows all the properties of electromagnetic waves. Methods of detection. Radio waves can be detected by aerials of radio and TV receivers. Sources. These waves are mainly produced by TV and radio transmitters, produced by cell phones, and natural sources like lightning and other astronomical phenomena. Uses. Radio waves are used in radar communication and in radio and TV transmission. Harmful effects. Excess of radio waves can lead to burns and body tissue damage. Thank you.
So from this presentation, we have got an overall view of the electromagnetic spectrum and what is an electromagnetic spectrum, what are invisible spectrum, what are the different kind of radiations in the electromagnetic spectrum, their common characteristics common in all of them, and their different characteristics and specialties in each one of them. So with this we come to an end of our slide of our presentation, and thank you to Annesha ma'am, our judge Mr. Onuran Chakraborty, and to all my friends to patiently see our presentation and to cooperate with us. Thank you.
Thank you, children. Thanks a lot. I'm now tensed how to teach you this chapter next day that you all know so much. You'll be questioning me on the topic. So I have to prepare myself nicely for the next day's class. So, Anuran, I'll send you the recordings of all. Rishita, are you ready? Are you inside? Sajat, is Rishita inside?
Ma'am, she told that she is her network problem. She
Yes.
working.
Okay, just find out. We'll wait for her to enter for. Otherwise, what we can do is, if she can't just enter, then you have to send me the recordings after this class. I will. I have recorded this PowerPoints also, so I will send it to your Onuran sir and give him a little bit of time to think over. Okay, next week's class I will declare his decisions. Okay, now he's a lovely person. Rishita, are you inside? Okay, so one thing, we'll wait for him. Onuran, we would like, can you just mute yourself, children? Now, let me introduce you to Onuran, sir. Now, he is from Don Bosco Park Circus, a lovely student. I'm not telling you, see, I've never seen a child so helping during his, when he was a student, children. Everyone used to love sitting beside him because whatever he did, he not only did for himself, he shared whatever he knew with others. And that's why today Onuran is Onuran. He got a very good rank and then he went to Jadavpur University. And remaining, you can, Onuran, can you just inspire us, all the children?
Hello, hello. Am I audible? Hello.
Yes, sir,
For
you are
your
audible.
future.
Yes, sir, you are audible.
Yes, sir, you
Okay.
are.
So first of all, I would like to thank Anusha ma'am for inviting me to this. Uh, Regarding the presentation, I would say you have done a really good job putting this together. As ma'am already said, that you did not even meet each other, and yet you have put a very good job putting together these presentations, trying to present from your mobiles or whatever you have, uh, even with your network issues and all. So yeah, I would say that it will be very difficult to judge that how and uh, who should be given first, second, or third. But what one thing, there are two things that I would like to say that right now in schools, the one of the most important things that we should be taught, I believe, is how to present. So that is a very very important issue that should be taught to everybody, about how to present, because that is something that you will be requiring throughout your life, be it professional, be it in your college, be it in your higher studies, because that is something you all will always need. So, firstly, what I would like to say is definitely none of us expect you to know all these guidelines for presentations, but this is my personal opinion and what I have formed from industrial experience, or you must say professional experience till now, that there are some guidelines that you must follow while you're giving a presentation. When you are presenting, you must know that the ones who are watching your presentation, they may not be having enough time to look at all the slides that you have written, made. Okay, so firstly, there should be no slide transitions and animation. It should be as plain as possible. So you just without no transition, so it is not distracting. And secondly, and moreover, when you are presenting over, let's say, over Meet or over Microsoft Teams, that animations take up more time to load. So these, try to avoid this. I'm not telling that you have not done a good job of doing, because I'm not expecting you to know all this, but these are my advice, that this is something you will need in the future also, presentations. And next is, do not put too much text into slides, and whatever you are presenting in a slide, that you must be speaking out, and do not read from the slides. You just write the keywords in the slides. uh, Also, I think it will help you this time also. Suppose you have written down all the keywords before your exams or something, you may you can use that presentation to brush up, because you cannot take your time to read through paragraphs. That is not always possible. Always write it in points. That will be useful in your exams as well. That is something ma'am also used to tell that always write in point form, because that is something that you must understand. So these are the two things that I had to tell you regarding a presentation. So try to follow it, because that is something you will need in the future. And regarding class 10, I ma'am is definitely ma'am has definitely inspired me a lot. So there is nothing much that I have to tell. But what I would say is, whatever ma'am tells, just listen to it. And ma'am had given me one very big suggestion, that is, before the exams, go through the syllabus that is there in the beginning of the book, or in that CISE, that guide, that where all the syllabus and all are written down. So I would say that you go through each and every topic that you have that is there in the syllabus, to just make sure that yes, I have covered everything. Do not miss out on anything. um, just make sure about that. That will be very very sad, that when you go in the, if you somehow miss out something. And ma'am used to take regular tests. I would say that yes, that was very very helpful. So that is something I would always recommend. I personally, I did not go for any mock tests and all. I only gave it in the tests in the tuitions. So that is something that I would say that is okay. Which I would say it's fine, and no need of mock tests, as far as I feel. And and one thing is that you have to keep sufficient time for self study also. So that is something that is very very important. You must give sufficient time to your self study, and ma'am is always there to help you out. So if you have any problem in physics, and especially she's there to solve anything. She's there, like if she can solve it, she will definitely help you with that. But she's there especially in physics. You don't have to think about anything else as long as she's there. So she will definitely help you. uh, that's what I would. That's what I have to say. That class 10, you must just concentrate on your self study also, not only tuitions. So giving exams and all, I would say that like in the tuitions itself. So that will help you prepare, and so obviously solving the past year questions. If I have very little idea about how the syllabus has changed over the years. Like I gave it 6 years back, so I don't have any idea. So like that much you have to check that how much it has changed and what are the things that are included or excluded. Thank you, ma'am.
Turnaround. Now, children, from this batch, I want some children coming out as toppers, and then I will send a message to Onuran sir that his speech has uh, inspired you all, inspired you all, and I want you all to come with flying colors. Now, uh, one more thing, children. I think Rishita can't join. I'll just give him a call. I'll give him a try. I'll give a try to call Rishita in the new mail. She can't join. Otherwise, we'll tell Rishita to send the recording, which I will forward to Onuran sir. I think she's given in the group. Mail.
ম্যাম যেটা তুমি আজকে করেছো ওইগুলো কল করতে একটু
Sir, just tell me the mail. Are you with the mobile? Are you inside? Can you just tell me the mail so that I can type it? Rishita, I've called you in the different mail. Nothing to
ওকে
be
ম্যাম
tense. Nothing to be tense. Just see whether you can join through that device. Otherwise,
আমি
you can.
জয়েন করছি
Someone else can present if she has a problem, right?
Yes, yes. The PowerPoint is she cannot give the PowerPoint to someone. It's in her laptop.
Oh,
But can you just give it to someone in your team?
screen sharing is costly in terms of the network, so I would suggest that give it to someone else.
Rishika,
Yes, ma'am.
are you in with the new device?
Yes, ma'am. I'm in with the new div.
Can you now present? Or
Yes,
should
ma'am.
we?
I'm present.
Now then, Team Viptio, get ready, children, with your presentation.
Yes, ma'am.
The last team. Rishita, no, don't be tense. It's nothing there, children. We all are learning. The first time, we all are learning. I'm also learning from you. So such a nice person Onuran sir is.
Okay, I'm presenting it.
Yes, come on. Can you raise your hand, Team Viptio? Rishita, start sharing.
Yes, ma'am.
Ma'am,
Yes, I
ma'am,
think
I do not getting the
option.
option.
Yes, yes. Bring up once again. I'm finding you out and making you the presenter. Yes. Yes, I've made you the presenter. It is loading, Rishita. So don't worry. It's loading. Team Vibgeo members, get ready. If you can share it in PPT form or PDF form, if you can share it in, see if it's not loading, you can give it in PDF form to someone who can share the screen. If it's not loading, it's a problem with your network issue, Rishita, I think. Can you
Yes,
share it?
ma'am. Today,
Yes, can you give it in
today.
PDF form to someone who can share the screen?
Yes,
Is it
ma'am.
in
I can
PDF
give.
form?
Ma'am, it opened.
Okay.
Ma'am, can you see my screen?
It's coming, it's coming. Rishita, the first slide is not here. As Anuran sir said, see two things I told my son also, he's listening over here. You
Yes,
have
ma'am.
to know how to present. Number one, he said that presentation should not carry too much of animations. Most probably you have given too much of animations, so it's taking time to load. Number two, he said don't write too many things on the slide because nobody will go through it. These 2 points are very important, which I have learned today from him. And I will tell my son to continue because class 10 is not the end, children. You have to go a long, long way. So when you present, you have to present in your colleges and after this henceforth. Two things. Avoid animations. Judges are not there to see how much animation you know, but what is your content, how you are covering your subject. They are not there to see your animations. And number two, write as minimum as possible on the slides. Shita, we do one thing.
Yes, ma'am.
Since it's loading, Can we give a try in the recording? Can you all record and send it to
Yes,
Anuran
ma'am.
sir? Don't worry, children. It
Yes,
happens.
ma'am.
It happens next time. Remember, Rishita, keep it in PDF form. So in case this happens, you okay, it's come, it's come.
Okay.
Ma'am,
Do
can I
one thing.
start?
Okay, start.
Good morning, our respected teacher, Ornesha ma'am, Judge Onron sir, and all our dear friends. Today, the team with Jor has got an ample opportunity for presenting. With Jor, the visible light rays of spectrum. Elucidation of the term. The electromagnetic radiations of wavelengths from 4000 angstrom to 8000 angstrom are called the visible radiations or visible light because in the presence of these radiations, other objects are seen by us. The light of different wavelengths produce the sensation of different colors of the retina of our eye, so we perceive them as different colors. The prominent colors of visible light are violet, indigo, blue, green, yellow, orange, and red. This order in the spectrum can be easily remembered by the word Vibgyor. Note: a general sketch of the spectrum formation has been provided in the next slide. This is the general sketch of the spectrum formation. The spectrum can be divided into two categories: visible light rays and invisible.
Rishita, you are muted. Can you just unmute yourself? Rishita, talk through the mobile. Talk through the mobile where you have logged in. Rishita, talk through the mobile you have logged in. Can you skip the animations?
Do one thing. Exit from presentation mode. Just scroll. Normal scroll.
Yes.
Okay, sir.
Children, just scroll as sir said.
Ma'am, I cannot not close the presentation. Means this
Do one
animation.
thing. Do one thing. Don't worry, children. You give the recording after this, and I'll send it to sir. And remember, next time we all have learned nothing to be sad. Okay, is it coming?
Yes, ma'am, it's coming.
That's because you have given too much of animations. So we do one thing. We are holding Anuran sir for a long time. So you give this recording after this, and children remember all of us, as Onuran sir said, we have seen a life problem. See, this is also, we have nothing to be sad. We have learned, I have learned, that during a presentation, we are not going to introduce so much of animations. So just, I don't want your team to be sad. A team leader should be sad who will inspire the team. Okay. So do
No,
one
ma'am,
thing.
I am not at all sad.
Okay. So do one thing, Sujat. Your team will get justice. Due to network issue, or you all are children.
Yes,
Just
ma'am.
after this class, after everyone leaves, you are going to enter my team, give the recording. I am going to forward the recording to Anuran sir. Okay,
Okay, ma'am.
children.
Yes, ma'am.
Okay, ma'am.
Okay. So don't be sad, and we all are learning. Anuran, thank you so much, so much, so much. Wish you a long, long way in your life. And I'm so proud that you are here, Anuran. We are so, so proud of you. Thank you so much.
Thank you, ma'am.
I'll send you the recording, Sonuran, so that you can have a good.
Yes, ma'am.
Okay. I'm ending the presentation. I'm ending the meeting here. Thank you everyone.
जाना